Good morning, class. Today, we're going to continue with the synthetic process to find zeros of polynomial functions. So we'll continue with the rational zero theorem. And we're going to use that to solve polynomial equations and find zeros of the polynomial function. Okay. So the rational zero theorem pretty much works like this. So let's say you have some function, f of x equals some a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, then you're going to have some a sub 1 x to the first power plus some a sub 0, which is your constant. So you have your constant, and then we have our leading coefficient. Well, all of the possible rational zeros, so our possible rational zeros are equal the factors of the constant term divided by the factors of our leading coefficient. So all the factors of our constant term divided by all of the factors of our leading coefficient. Those give us all of our possible rational zeros. So what do I mean by a rational zero? So let's say we had a function such as f of x is equal to x plus 3 times 2x minus 1 times x plus the square root of 2 times x minus the square root of 2 times x minus 4 plus 5i times x minus 4 minus 5i. Okay. I think we've said before that if you have a solution that's a radical in it, that the conjugate will also be a solution. The same with the complex. So with these sets of zeros, here we have a zero of negative 3. This is a 0 of 1/2. This 0 is negative square root of 2. This 0 is positive square root of 2. This 0 is for minus 5i, and this 0 here will be for plus 5i. Okay, so those are all values that you can plug in here for x. That's going to make that particular factor equal to 0. And then with our zero product property, 0 times anything is 0. Well, these 4 are real solutions. And these 2 are complex imaginary solutions. Now, out of our real solutions, we have rational and irrational. So these are real. Irrational numbers are also real numbers. So the -3 and the 1/2 are irrational solutions. It's a ratio. You can form these numbers by taking the ratio of integers. And the negative square root of 2 and square root of 2 are irrational solutions. So what the theorem that we're going to cover now deals with is possible rational solutions. Okay. So how do we use this? Let's take a look at an example. So let's say we have f of x is equal to -x to the 4th plus 3x squared plus 4. Right, so it's written in standard form. Here we have a function that's of degree 4. So our possible solutions, possible rational solutions for zeros, possible rational zeros, are equal to, well, we take a look at our constant. What are all of the factors? Well, it's going to be 1 plus or minus 2, and plus or minus 4. Then the reason you have plus or minus here, because a -1 times a -4 gives us a positive 4. So you're always going to have the plus or minus. The leading coefficient here is -1. So the only factors of -1 are plus or minus 1. So here are all of our possible rational zeros. So it's the ratio, so it's plus or minus 1 divided by plus or minus 1. So that's going to give us plus or minus 1. 2 divided by 1 is 2. And 4 divided by 1 is 4. So in this case, we have 6 possible rational zeros. So what we could do is we could use synthetic division to see if we can figure out which one of these are rational zeros. So we'll take a look at that in a sec. All right, so let's take a look at another example. What are all of our possible rational zeros with the following? So next example, list all possible rational zeros for f of x is equal to 15x cubed plus 14x squared minus 3x and minus 2. So our possible zeros. All right. So our constant is 2. The only factors of 2 are 1 times 2. So we have plus or minus 1 and plus or minus 2. 15, on the other hand, is 1 times 15 and 3 times 5. So your possible factors are 1, 3, 5, and 15. So plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. So all of our possible zeros, first we're going to take this plus or minus 1, and we're going to divide it by all of these. Then we're going to take the plus or minus 2 and divide it by all of these. So our possible zeros are plus or minus 1. 2 divided by 1 is 2, plus or minus 2. Okay. Now 1 divided by 3, plus or minus 1 over 3. 2 divided by 3, plus or minus 2 over 3. Now 5. 1 divided by 5, plus or minus 1 over 5. 2 divided by 5, plus or minus 2 over 5. And then finally, we deal with the 15. Plus or minus 1 over 15, plus or minus 2 over 15. So out of all of the possible zeros here, you have 2, 4, 6, 8, 10, 12, 14. You have 16 possible rational zeros. Now, those are only possible zeros. So you have 16. So how do we know if we're going to use synthetic division, which one to try? Because not all of these are going to be. As a matter of fact, at most 3 will be zeros. So that means 13 of these will not be a zero. So when we're looking at this through synthetic division, we don't want to work through this 13 times before we get one that works. All right. So again, there's 16. The ones that actually work here are -1, -1/3, and 2/5. Those are the set of our zeros there. Okay. So now let's go ahead and find the zeros. So now we're going to use this information of possible zeros to actually find some zeros. Okay. So finding zeros of a polynomial function. All right, so let's take a look at this example. So we have f of x is equal x cubed plus 2x squared minus 5x minus 6. So let's say we had to graph this and we were trying to find our x-intercepts, right? So here, this one actually does not work out to factor by grouping, because you get x squared times x plus 2 minus 1 times 5x minus 6. So we would not be able to factor this one by grouping. That doesn't mean that it doesn't have x-intercepts. So here are possible zeros. Well, our constant 6 is 1 times 6 and 2 times 3. So we get plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Our coefficient, or our leading coefficient here is 1. So that's just plus or minus 1. So dividing these by 1, you're going to get 2, 4, 6, 8. So you have 8 possibilities. All right, so now we start testing. All right, so let's test the 1. So if we test 1, write down the coefficients of our polynomial. So that's 1, 2, -5, -6. We bring down our 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. -5 times 3 is -2. 1 times -2 is -2, so we get a -8. So 1 is not a 0. So let's try -1. 1, 2, -5, -6. Bring down the 1. -1 times 1 is -1. 2 minus 1 is 1. Negative 1 times 1 is negative 1. Negative 5 minus 1 is negative 6. Negative 1 times negative 6 is a positive 6. And there we have a 0. So, x minus 1, or sorry, not x minus 1, negative 1 is a 0. So that means that x minus a negative 1 or x plus 1 is a factor. So with where we started here, since this is a 0, we can rewrite this as x plus 1 times, and now here are the coefficients of our remaining polynomial. So that's, because it started at x to the third, this will be x squared plus x minus 6, and that's equal to 0. So we already know negative 1 is a 0. Okay. Now this part right here, if we can factor this, we can find the remaining two zeros. If not, we would have to use the quadratic equation. So here, that's x, that's x. Now we need to get a positive 1x here, and whatever numbers we here need, when we multiply them, we need to get negative 6. So I think 2 and 3 work. X times 2 gives us 2x, x times 3 gives us 3x, but we need a positive x there, so this needs to be negative, so the 2 is negative. Okay, so this x squared plus x minus 6 factors into x plus 3 times x minus 2. So we have x plus 1 from here times x plus 3 times x minus 2. So our three zeros are negative 1, negative 3, and 2. But we already knew negative 1 was a 0 because we tested it out here. So we had 8 possibilities. Notice that out of all of your possibilities, we ended up with negative 1, which was a possibility here, negative 3, and 2. So all of your rational solutions will come from your set of possibilities. So we had 8 possibilities, only 3 worked, so that means that 5 did not work. So when you're testing these out, sometimes we just get a little lucky with how we choose them. Okay, let's go ahead and try another one. Okay, so let's say that we have f of x, and that is equal to x cubed plus 7x squared plus 11x and minus 3. Okay, so what I notice here is that we cannot factor by grouping. So here, possible. It's not too bad here because the only factors of 3 are 1 and 3. So you're going to get plus or minus 1 and plus or minus 3. The coefficient, your leading coefficient here is a 1. That's divided by plus or minus 1. So here you only have 4 possibilities. So that's actually not so bad. So you have plus or minus 1, plus or minus 3. So let's go ahead and test these out. So if we test out the 1, then our coefficients are 1, 7, 11, negative 3. Bring down the 1. 1 times 1 is 1. 7 plus 1 is 8. 1 times 8 is 8. 11 plus 8 is 19. 1 times 19 is 19. And we are not going to get a 0 there. So 1 didn't work. So let's try negative 1. 1, 7, 11, negative 3. Bring down our 1. Excuse me. Negative 1 times 1 is negative 1. 7 minus 1 is 6. Negative 1 times 6 is negative 6. 11 minus 6 is 5. Negative 1 times 5 is negative 5. And here we get a negative 8. So that didn't work. At least we only have 4 and not 16. So let's try the 3. So that's 1, 7, 11, negative 3. Bring down the 1. 3 times 1 is 3. 7 plus 3 is 10. 3 times 10 is 30. 11 plus 30 is 41. And then 41 times 3, I think, is 123. So here, our remainder is 120. So that one didn't work. So it's starting to seem like none of these are going to work. But let's go ahead and try that last one, negative 3. So here you have 1, 7, 11, negative 3. And by the way, if this one doesn't work, what that means is that we don't have a rational solution, a rational zero. Doesn't mean that we don't have zeros, because we do. We'll talk about the fundamental theorem of algebra in a second. Just means that we wouldn't have any rational zeros. But let's try this one, you never know. Negative 3 times 1 is negative 3. 7 minus 3 is 4. Negative 3 times 4 is a negative 12. 11 minus 12 is negative 1. And then negative 3 times negative 1 is a positive 3. And there we have it. So because negative 3 is a 0, x plus 3, x minus a negative 3, or x plus 3 is a factor. So x cubed plus 7x squared plus 11x minus 3, we can factor it into x plus 3 times x squared plus 4x, and then minus 1. All right? So here, negative 3 is a 0. We showed that. Now we need to find the 0 here. So we have it, have it reduced to a quadratic. Here, we can't factor this because only factors of 1, negative 1 are 1, negative 1, and you have an x and x. There's no way multiplying we're going to get a 4x. So here we are going to have to use the quadratic equation to find our remaining two zeros. Now they could be either radical or they can be imaginary, we don't know. So a is 1, b equals 4, c is equal negative 1. X is equal the opposite of b, plus or minus square root, b squared minus 4ac, and the whole thing divided by 2 times a. So that's going to be negative 4 plus or minus square root of 4 squared minus 4 times 1 times negative 1 all over 2 times 1. And it's negative 4 plus or minus square root. So 4 squared is 16 minus a negative, so that's plus 4. So that'll be square root of 20 divided by 2. And then we should know that 20 has a perfect square factor, so the square root of 20 is the same thing as the square root of 4 times the square root of 5, or 2 square root of 5. All right, so this now becomes negative 4 plus or minus 2 square root of 5 divided by 2. And 2 goes into both of these terms evenly, so that'll be negative 2 plus or minus square root of 5. So your other two zeros are going to be, well, we've already established that we've already established that negative 3 is a 0. So our zeros are negative 3. Then we're going to have negative 2 minus the square root of 5, and negative 2 plus the square root of 5. So those are all of your zeros. Okay. All right, so that's it for the lesson. Here's your homework for tonight. Okay, so your homework is section 2.5, page 377. And you guys are going to do problems. Let's see. We'll do problems 2 10 through 24 even. I think that comes out to be 8 problems. So 10 through 24 even. All right, you guys have a nice rest of the day, and I'll see you tomorrow.